Hello. I want to review what we did in class a little bit today and then bring it to some more problems and kind of lead us into the next lesson. And don't forget that after you watch this, to take the quiz on Blackboard to show that you watched the video. Okay, so today we talked about area, and we've got the area of a rectangle, which I actually didn't draw here, would just be our length times our width, right? We talked about the area of a parallelogram, which would be our base times our height. Remember, our height comes down at a perpendicular. It's the distance between these parallel lines, okay? And then we did the area of a triangle, which is just like a parallelogram, except it's half of it. It's divided by 2, right? So half the base times the height, and your height, again, is a perpendicular distance directly down from the top of the triangle to the base. Or you can write it as base times height divided by 2. A lot of students like that. And then we have the area of a trapezoid, where we have 2 bases now, A and B, and we're going to take half of the height, again the perpendicular, times A plus B, and make sure you do your parentheses first, okay? So this is where we left it today, and we started to think about compound area problems. So we can see from this type of problem, if I'm trying to find the area of this figure here, this is where we're going to start. It doesn't have a nice, neat little formula, so we need to cut this shape up into other shapes that we are familiar with. So what we can do, and there are multiple ways of doing these, is I could drop down a perpendicular right here, and now I'm going to have the area of a rectangle here, okay, this rectangle, plus the area of this triangle. Okay, so with that, we want to be thinking, all right, I'm going to write right on top of this. If I've got a rectangle, remember my area is equal to my length times my width. So I can call that my 5 inches times my 4 inches. So 5 inches times 4 inches. This is going to give me 20 inches squared. All right. So I've got my first part of this. And then I need to do my triangle here. Let me zoom in a little better. Okay. So now I've got to figure out, well, how can I get my triangle to be 1/2 base times height? How can I figure out what's going to be my base and what's going to be my height? Well, let's think about it here. If I've got 5 inches all the way for this whole distance, and I know that this distance is 3 inches, that's going to leave me with this space across here. If I make an imaginary line here, this space from here to here, this distance is going to be the difference between 5 and 3. So I'm going to have 2 inches for this space, which you can see here, right? And then I'm thinking, well, I've got to figure out, well, what's this distance here, right? So I'm looking closely at my whole figure, and I can see that if I drew this kind of all the way across, I could see that this is 4 inches here, and pull that down. So from here to here is my 4 inches. And then from here to here is going to be the difference between 7 inches and this 4 inches. That's going to be what's left over from this space from here to here. All right, so what I would have is 4 inches plus this would be 3 inches, would give me my entire 7 inches. All right, that is the idea of how I can figure this out. Now I've got 2 inches and 3 inches, and now I can do my 1/2 times my base times my height. I can call my base the 3 inches, 1/2 times 3 times my height is 2 inches. And from this, I'm going to end up getting 1/2 times 3 times 2. And in fact, put that right in your calculator if you're struggling with how to do this. And what you're going to end up getting is 3, and this is going to be square inches. Don't forget to use square inches. And now in the end, I am just adding these values together. So remember here I got 3 inches squared, and here I got 20 inches squared. So in the end, you take the area of this guy, 20 inches squared, plus your 3 inches squared, you get 23 squared inches, okay? There are other ways to do the same type of problem. We can analyze that. Okay, I'm going to do the same problem a little bit differently to show you that there are multiple ways. So you can see that I drew the same picture from, we just figured it out by getting the area of the rectangle plus the area of the triangle here. I'm going to do the same exact problem, and I'm going to do it a little differently, and I'm going to get the same answer, okay? So now when I'm envisioning this, I'm seeing two shapes, and they're different shapes this time. I'm seeing that I have a trapezoid here, and I have a rectangle here. Now I'm going to take area of the rectangle plus area of the trapezoid. That's our goal. Area of rectangle plus the area of the trapezoid. All right. So first find the area of the rectangle. We know that area is equal to length times width. So in this case, I'm going to have my area this is my length, this is my width. Either way you want to cut it. And I'll have 4 inches times 3 inches. I will get my area is 4 times 3 is 12 inches squared. Remember, these are square units. Okay. Then I've got the area of the trapezoid. So now I need to figure out my trapezoid formula. First of all, I will go right here. The area of a trapezoid is 1/2 the height times A plus B. So the key is remembering that your A and your B are your bases. So this can be your A. Your 7 inches can be your A. Your B can be the top base, right? So this can be your B. And if I want to know the length of this, I'm just going to drop this 4 inches down, and this 4 inches is going to be my B, right? And then your height is when you drop a perpendicular, and we knew that this was a perpendicular because it was actually given in the beginning that this is a right angle here, right? And it's the same picture. All right, so this is my height. And again, I have to figure out what is the value of this height right here. All right, well, if this entire length here is 5, and then this bit of it is 3 here, I'm going to figure out what this section is by taking the difference. If I take this 5, subtract off the 3 that's right here, I'm going to have 2 left over. So there's 2 inches here, from here to here. There's 3 inches from here to here, if that makes sense. 2 plus 3 gives me my original 5. All right, so now I've got my height is equal to 2. And I'm just going to plug these numbers right into the formula. And then just use a calculator. So I've got 1/2, my height is 2 times A plus B. My A is this base, 7, plus my B is this other base, the top base, 4. All right, go ahead. You can use a calculator, which I'll go ahead and pull out right here. And I'm just plugging in. Well, actually, what do I do first here? I've got parentheses. You always want to do the parentheses first. So I've got 1/2 times 2 times my 7 plus 4 is going to be 11. And now I've got a really simple problem. If you prefer to use, instead of 1/2 as a fraction, you can write this as 0.5 times 2 times 11. Put that right in your calculator, 0.5 times 2 times 11. What are you going to get? It actually works out nice and neat that it is 11 square inches, because we are in inches, for your trapezoid. And then what you're doing is adding the area of the rectangle, which we just said was our 12 inches square. So 12 squared inches plus the area of the trapezoid, which we just said is 11 inches squared, you will get 12 plus 11 is the same 23 square inches that we got when we did it the other way. Remember? We did it this way, and we did a rectangle plus a triangle, and we got the same answer. All right, so multiple ways to do these problems. Okay, we're going to look at another problem here, and we are going to come up with a plan of how to find the area of this figure for number 15. So again, I caution you, you do need to think about a plan before you just go after it. So I will say that I have thought about this, and this is what I'm going to do. I'm going to divide this up into a trapezoid here, which if you flip this, you can see how this is a trapezoid with my bases, right? My A and my B, and my height is here. All right. Then I'm going to drop down another line. So I've got two rectangles and a trapezoid. I'm going to start by trying to get my area of this trapezoid, which is 1/2 the height times A plus B. All right, well, again, this is going to be a base, and this is going to be a base. So I've got this base is 7. This base, I don't know what this is. I'm looking across here and trying to see, can I get this distance here? Well, this is 9. And then bring over this 3, carry this over, and this whole distance now is going to be 9 plus 3, which is 12. Okay, so I've got A and B figured out. So I've got 12 plus 7. I'm going to have my area is 1/2 times the height. Well, this is my height here, this perpendicular right here. So how can I get that? Well, again, I see this is 15, but the whole way across, if I drop down this 6 here, 6 centimeters here, the whole way across is going to be 15 plus 6 is 21 centimeters. See that? How 15 and the 6 gives me 21 the whole way, right? Okay, well then if I crawl up here, this is 17. So I'm looking for this difference here. I want to know the total 21 minus this 17 piece here is going to give me what's here, right? So this is actually going to be equal to 4. So this height here is going to be equal to 4. All right, so now I have what I needed. My area is 1/2 my height, which is 4, times the 12 plus 7. Do your 12 plus 7 first, you're going to get 19. I'm going to have A equals 1/2 times 4. Well, if you're not comfortable with doing this in your head, you can go ahead and pull out your calculator, and you are doing 1/2, which is 0.5. Turn the calculator on. 0.5 times, we've got 4 times 19. Figure it out there, you got 38. Area of this is going to be 38, and this is centimeters squared, right? So I've got 38 in here. Just circle that. Next, I want to find the area of this rectangle here. Well, sorry, my camera cut out, so I need to start again right here. So now I was just finding the area of this box, and we already decided that this length here is 12, and I need area is length times width, so I need this segment here. Well, we decided earlier that we've got 21 the whole way across, so I need to subtract off this 4 and subtract off this 6. So I'm going to get 21 minus 10 is 11. So we've got 11 for this distance here, and I've got length times width. A equals 12 times 11. Put that in your calculator, 12 times 11. You get 132 for this box. All right, now I'm almost done, and I just need this box right here. So I'm going to do the area of this, and again, it's length times width. And I have this one. I've got 6 times 9. I get 54. In the end, I'm just going to add all these up. 38 plus 132 plus 54. And I get, use your calculator, 38 plus 132 plus 54, 224. Final answer, centimeters squared. All right, you might wonder where I'm going with all of this. And we're moving towards something called surface area, which imagine you have a 3D figure like this rectangular prism here, which I have it folded together, right? Well, when you're finding the surface area, you're really kind of finding, you've got a 3D figure and you're finding the area that goes all the way around this figure. Kind of like if I were to wrap this box in wrapping paper, find the area of each face and then add them all together. And so in reality, it is exactly what we've already been doing. All right. If I unfolded this box, it would have 6 faces. It would have this 1, 2, 3, 4 rectangular boxes, and then these were our bases here. So we'd have 1, 2, 3, 4, 5, 6 faces, and you would just need to compute the area just like we've been computing these other figures. So for example, if I said, okay, this box here is 4 centimeters by 4 centimeters, and I said, I'm just making these numbers up right now, that all of these, well, if this is 4 centimeters and it's a box, all of these must be 4 centimeters as well, right? And then my length here, I'm just going to make up is, we'll do 7 centimeters, right? And then this box is the same as this box, 4 centimeters, 4 centimeters. So really, I would be finding the area of all of these faces and adding them all together. So I'm going to go ahead and try to compute this. So let's go box by box. So if I'm computing this area here, for this box, I will have 4 centimeters times 4 centimeters. I will get 16 centimeters squared. And likewise, this box is 4 centimeters times 4 centimeters. So I'm going to abbreviate here 4 by 4. I will get 16, and these are centimeters squared. And then I can keep going with all of these 4. I'm going to have 4 by 7. So 4 times 7 gives me 28. And then this is going to happen 3 more times, right? 28 centimeters squared, right? This is going to be 4 by 7. So again, 4 times 7 equals 28 centimeters squared. Again, 4 times 7 for this box. 28 centimeters squared. And then the last one, 4 by 7. Okay. Then I should have 6 faces here. I should have 16, and I'm adding them all together for the area, plus 16 plus 28 plus 28 plus 28 plus 28. There should be 6 of them, right? 1, 2, 3, 4, 5, 6. That's all of these faces. And to get the surface area of the entire figure, I add them all together. So imagine I am adding these here. So I'm going to have in my calculator 16 plus 16 plus 28 plus 28 plus 28 plus 28. 4 28s there. Add them all up. You're going to get 144. And these are centimeters squared. So that would be your answer for this particular box. Now remember, this was a 3D figure, right? And we found the surface area of a 3D figure, not to be confused with volume. We will do volume in this class, but this is to be taken as an area here. This is really a 2-dimensional figure, all right? We're going to get into this a lot more, and we're going to do all kinds of different figures. So I just wanted you to see it before you get to class so that it's not so fresh when you get there, okay?